Hello everyone. Hi, welcome back to the class. I hope you all are doing great. So I hope last chapter alcohol phenol ether is fully clear for you. Nobody is having any doubts, right? So now we are going to start with the next part, that is carbonyl compounds. Carbonyl compounds, and according to NCRT the name is aldehyde ketones and carboxylic acid. So we are going to divide this chapter into two parts. In part A, we are going to talk about aldehydes and ketone. In part B, we'll be talking all about carboxylic acids, right? Again, most of the reactions will be similar. So many mechanism will be exactly same what we have done in this many chapters, right? Till now, whatever we have done, same thing we have to do. Correct? Chal. So let's start and let's start with the carbonyl compound. What is carbonyl beta? Carbonyl का मतलब क्या होता है? Carbonyl is C double bond O. This is called as carbonyl. Okay? This compound is called as carbonyl. Now, if we have any derivatives of this one, matlab, let's say if I attach H over here, RH, it becomes aldehyde. And let's say in this carbonyl compound, if I attach carbon chain on both the side, ये क्या बन जाएगा बेटा? ये बन जाएगा मेरा ketone. This is my ketones, right? Correct. Now, these carbonyl compounds are also what to say reactive in nature. Why they are reactive in nature? Because we say that this carbonyl carbon जो होता है ना, carbonyl carbon is polar. This molecule is a polar. The bond between them is polar. Why the bond is polar? देखो बेटा, polarity how do we define? We define polarity based on the difference in electronegativity. So here the electronegativity of oxygen and carbon, they are different. So I can say that due to difference in electronegativity difference है किसके बीच में? Due to difference in electronegativity between oxygen and carbon, carbonyl compound, this one becomes polar. This is my polar compound, and if it is polar, so I can break this bond. How I can break this bond? I can break this bond like this. So this will get delta minus, this will get delta plus. Now this carbon क्या बन गया? Carbon became electron deficient. So any nucleophile or any compound which is electron rich, that can attack to this carbon. So in this way, we can have different types of reactions which we are going to study in this chapter. Okay? Chalo, so let's start with the very first part of this chapter, that is method of preparation of aldehydes and ketones. We are going to do both the things simultaneously, right? So let's go with method of preparation. Kiska? Aldehydes and ketones. So the very first method that we are going to do, it is from alkenes. From double bonded carbons, we can also prepare the what to say? We can prepare the aldehydes and ketones. How can we prepare? Can you recall any reactions that we have learned till now from double bonded? Yes, we have learned a reaction called as ozonolysis. Correct, where we do the reaction of double bond with ozone. But there are two types of ozonolysis. एक पढ़े थे हम reductive ozonolysis. One we have done oxidative ozonolysis. If I want aldehydes or ketone, beta I have to do reductive ozonolysis. If I want carboxylic acid, then I'll go with oxidative ozonolysis, right? So first method is by ozonolysis. Ozonolysis. Now, how to do this ozonolysis? I hope you remember. Let's say I have a double bonded carbon. Let's say this is my alkene CH2. ठीक है, reaction को हम किसके साथ करते हैं? First, there will be ozone, and second, I'll be using reductive ozonolysis, any reducing agent. I can use any metal like let's say zinc in water. This is referred to reductive ozonolysis, right? So, if you remember the trick, I have told you the direct way, right? Mechanism we have already covered. Now, we can go directly with trick. What was the trick? Just break the double bond and add oxygen on both the sides, right? So, there will be two products. बेटा एक product बनेगा ketone and another product will be HC double bond OH. मतलब one is my aldehyde और एक बन गया ketone. This is how we can do this reaction. Now, let's say, suppose if examiner gave you some question like in this following reaction, in the above reaction, let's say I have added a reducing agent. जैसे यहाँ पे मान लो I am adding LiAlH4. Now, about LiL lithium aluminum hydride, Remember we have learned क्या होता है, it is the strongest reducing agent. अब ये reducing agent क्या करेगा, the strongest reducing agent, it will reduce the ketonic carbonyl carbon into alcohol. मतलब यहाँ पे product क्या मिलेगा, I will be getting 2 degree alcohol, I will be getting secondary alcohol. Correct? If I treat with lithium aluminum hydride, this is the strongest reducing agent. याद रखना. वैसे similarly, in aldehyde, if I add LiLH4, will there be any reaction? The answer is yes. Why? Because यहाँ पे भी तो carbonyl carbon है. Wherever there is carbonyl carbon, beta carbonyl carbon is going to convert into alcohol. यहाँ पे product will be methanol. This is 1 degree alcohol or methanol you will be getting. In this way, we do the reaction. Now, देखो एक और क्वेश्चन, लेट्स से if they are asking for competitive exams, right, how they can twist. So they will give you something like this was the reaction, you got two products A and B. Now both A and B was treated with a strong reducing agent, let's say LiLH4. You got C and D. Now they will ask you how you can identify between C and D which one is primary alcohol, which one is secondary alcohol. कैसे करते हैं? फॉर दिस इफ यू रिमेंबर वी हैव लर्न अ टेस्ट. क्या होता है? लुकास रिएजेंट टेस्ट. क्या करते हैं लुकास रिएजेंट में? वी डू द रिएक्शन ऑफ alcohol with HCl in presence of ZnCl2. And in this reaction क्या होता है? If you have 3 degree alcohol, so 3 degree alcohol में क्या होता है? Immediate turbidity, instant turbidity. 2 degree turbidity in minutes. And 1 degree they do not give turbidity, or it takes very long time, right? It gives turbidity in hours that we say. तो यहाँ पे क्या होगा? The product will become Cl and it will give turbidity. So in this way I can differentiate also. So this is one of the method to prepare aldehydes and ketone carbonyl compound. देखो यहाँ से ketone also I got the aldehyde. So from alkene, if you want to prepare, what you can do? You can do the reaction with ozone in presence of ZnNH2O. याद रखना, this is called as reductive ozonolysis. This is called as reductive ozonolysis. Let's say if I would have taken oxidative, then यहाँ पे instead of aldehyde मुझे क्या मिलता? I would be getting carboxylic acid, right? Because it will oxidize the aldehyde group, और aldehyde oxidize होकर क्या बनेगा? It will form carboxylic acid. I hope this is clear for everyone. Great. So let's move forward now. Chalo. Now let's say चलो let's do one more question. ठीक है, I'll give you one more question for practice. So better take your time and try to solve this one. Let's say you have this alkene and they have given you treat this alkene with ozone in ZnHCl. Not HCl, ZnH2O. Drink in water. You will be getting two products A and B. Okay, they have told you that we have to do reaction of only A with n mole of CH3MgBr. I hope you know what is CH3MgBr, Grignard's reagent, right? And in second step, you have to do hydration, H plus water. You will be getting a product C. Treat this product with the Lucas reagent HCl in ZnCl2, and you will be getting instant turbidity. So I want you to try this one once. एक बार try करो. So, देखो, in this one, we know that first step is reductive ozonolysis. This thing told me that I am doing reductive ozonolysis. Reductive ozonolysis में, if I do with this one, the trick is very simple. Add oxygen in both sides. So I can see clearly that one will be aldehyde, one will be ketone. Chalo, let's draw the product. So one will be something like this, double bond O, and another one will be double bond OH. So one is aldehyde, one is ketone. Now, I don't know which one is A, which one is B. How to identify which one is A, which one is B? With the help of next type of reaction. देखो, out of these two, any one I have to do the reaction. After doing reaction, I'll be getting a reaction with Grignard's agent. I'll be getting something called as C. आफ्टर दैट इफ आई एड लुकास रिएजेंट इंस्टेंट टर्बिडिटी, इसका मतलब क्या होगा, C जो बनेगा, C इज माय टर्शियरी अल्कोहल, दिस शुड बी माय 3 डिग्री अल्कोहल। बताओ क्लियर है? सो इफ इट इज 3 डिग्री अल्कोहल, इन विच केस टर्शियरी अल्कोहल इज पॉसिबल। देखो बेटा, अगर इफ आई डू द रिएक्शन विद दिस एल्डिहाइड, ठीक है, CH3 MgBr, आई होप ग्रिग्नार्ड रिएजेंट, यू नो दैट ग्रिग्नार्ड रिएजेंट क्या करता है, we have learned CH3 MgBr, it gives CH3 minus MgBr plus, so R minus will be there, so R minus क्या करेगा, R minus will attack from here, and in this one also R minus will attack here. Let's say if it attacks here, तुमको क्या मिलेगा, you will be getting O minus, यहाँ पे CH3 group. If I do the attack on aldehyde, what I'll be getting, बेटा aldehyde में reaction करो, यहाँ पे आ जाएगा O minus, यहाँ पे आ जाएगा CH3, मतलब सीधा सवाल, in next step H plus water you convert O minus into OH alcohol, इसको O minus को alcohol करो, so I can see clearly ये है 2 degree alcohol, ये है मेरा 3 degree alcohol, so which one is A, 3 degree alcohol वाला compound is my A, so this will be my A, this will be my B. I don't have to do the reaction with this one, I'll do the reaction only and only with A. So R minus CH3 minus will attack here, this bond will break like this, तुमको मिल गया यहाँ पे CH3 alcohol मिला. Now you add Lucas reagent, if I add HCl in ZnCl2, क्या होता था बेटा, Lucas reagent, it will displace the OH and you will add the chlorine here, बस यहाँ पे you remove this one CH3, you add Cl, and this will give you instant turbidity. ये आएगा instant turbidity, why, because it is 3 degree alcohol. क्या ये चीज क्लियर है सबको? I hope this is clear for everyone, right? Cool. चलो, so let's move forward now. We'll move forward. Now we have done one method from alkene, that is by ozonolysis. Now if you remember बेटा, हमने एक और reaction पढ़ा था, that is from triple bonded. I can also prepare aldehydes and ketone with triple bonded compounds. How to prepare? There was a reaction, if you remember, that is called as Khusrov's reaction. That is called as Khusrov's reaction, and Khusrov's reaction is done with alkynes triple bonded, right? And triple bonded में हम क्या करते थे? We used to do the trick याद करो क्या था? Markovnikov addition of water, right? So यहाँ पे हमारे पास रहेगा triple bonded compound. Let's say RC triple bond CH. This is my alkyne. Khusrov reaction में what was the reagent? Reagent was dilute H2SO4 in presence of dilute GSO4, right? अब एक और चीज देखो, direct step तो you know, right? Markovnikov addition of water. Now what is the use of dilute HgSO4? याद करो, it dilute HgSO4 क्या करता था? It used to make non-classical कार्बोकेटाइन, राइट? ये बना रहा था नॉन क्लासिकल कार्बोकेटाइन. व्हाट इज नॉन क्लासिकल कार्बोकेटाइन बेटा? आर सी डबल बॉन्ड सी एच, यहाँ पे आके हमारे पास आ रहा था एच जी लाइक दिस, इफ यू रिमेम्बर, राइट? देन H2SO4 से वाटर आएगा, इट यूज्ड टू अटैक, दिस वाज एक्टिंग एज अ कैटलिस्ट. याद आया? यस, परफेक्ट. सो नाउ हियर व्हाट वी विल बी डूइंग, वी विल बी डूइंग वेरी सिंपल Markovnikov addition of Markovnikov addition क्या बोलता है बेटा? Markovnikov addition of water, it says that you have to add water on the most stable carbon, या ऐसा carbon in which plus charge carbocation is maximum stabilized. Now देखो carbocation, this is 1 degree carbon, this is 2 degree carbon. हमको पता है carbocation का stability is 3 degree, 2 degree, 1 degree. So in this one carbocation will be more stable. So I'll break this bond like this. So एक बार break करो, what I'll be getting? I'll be getting C double bond CH2 and here water OH positive. Now remove H plus, make it neutral. RCOH double bond CH2. Now बेटा देखो, actual reaction में, in actual mechanism, if you recall the actual mechanism, what we used to do? We used to do tautomerism, right? हम हाइड्रोजन को यहाँ से यहाँ we used to shift. I used to shift this one like tautomerism, and हम क्या करते थे? I have to convert this thing into ketone like this. But right now, no need to do this one. Let's say exam में you are forgetting about tautomerism. You don't know how to do tautomerism. Simple sa thing. You convert double bond or triple bond into single bonded. and to break each double bond you add water. मतलब if I want to do direct step, let's say I want to do this reaction directly, I don't remember the mechanism, how I'll do in exam. देखो एग्जाम में मैं क्या करूंगा, I'll write R C triple bond CH, ठीक है. यहाँ पे I'll break the bond like this. If I break the bond like this, I'll write C double bond CH2. यहाँ पे I'll write OH, correct. Then again I'll break the bond, double bond है, फिर से तोड़ो, फिर से ऐड करो water. If I add water again, I'll get OH, OH. Now CH3. Now remember one more thing I have told you, that two alcohol in same carbon is highly unstable. Agar this is highly unstable, then what will happen beta? यहाँ से always there will be loss of water. यहाँ से water molecule will be lost. If water molecule is lost, तो यहाँ से क्या होगा? OH and H will be lost और ये बन जाएगा RC double bond OCH. Correct. In this way we used to do the reaction. I hope clear hai, right? Iska mechanism is also clear for you, right? How to do the mechanism and all. I hope you know the little bit idea and all. Correct. Perfect. Chalo, great. Now we'll move towards the next method number 3. देखो, we can also prepare aldehydes and ketone from alcohols. Yes, from. Can anyone tell me how I can prepare from alcohols? Yes, beta, correct. To prepare from alcohol, I have to do oxidation. Now, oxidation करने के लिए I need oxidizing agent. What type of oxidizing agent I can prefer? Strong or mild? Mild. If I take a strong oxidizing agent, I'll be getting carboxylic acid. But मुझे carboxylic acid नहीं, I want aldehydes and ketone. For that, I have to take mild oxidizing agent. So if I do the reaction with the mild oxidizing agent always gives you the corresponding aldehydes or ketone based on the degree of alcohol. अगर primary alcohol है, then aldehyde. Secondary alcohol है, then ketones. Perfect. Now, if you remember, we have learned about few mild oxidizing agent also. क्या क्या पढ़े थे? We have learned something about PCC, pyridinium chromate, right? एक हम पढ़े थे PDC, pyridinium dichromate, right? We have learned about Collins reagent also. Collins reagent, if you remember. And where a Collins reagent, ये कहाँ पे act करता है? ये याद रखना, Collins reagent is only reacts on allylic or benzylic position. Allylic or benzylic position या फिर benzylic carbon. Only allylic and benzylic if you have, वहीं पे Collins reagent will attack. बाकी केस में no attack. ठीक है? Remember this point very nicely. Do not get confused. वैसे we have seen so many things. अच्छा बेटा एक और होता है copper heating. Sometimes ना in exam they will be mentioning temperature. Copper in 300 degrees Celsius. These all are called as mild oxidizing agent. ये सब हमारा क्या है? Mild oxidizing agent. So basically if I take any alcohol, मान लो मेरे पास है RCH2OH. I have added a mild oxidizing agent. ये क्या है? This is my 1 degree alcohol. अगर primary alcohol है, always primary alcohol will be converted to aldehydes. If I take RCHOH R dash and if I do the mild oxidizing agent, then क्या मिलेगा बेटा? I'll be getting ketone always. मतलब याद रखो, if you have primary alcohols gives you aldehydes, secondary alcohols give you ketones. बताओ, is it clear? Is it clear? Now, Collins reagent कहाँ पे ऐड करेगा? Collins reagent will only attack on the benzylic and allylic position. मतलब let's take an example. If you have forgotten this one, then मान लो if they have given you something like this. यहाँ पे you have one alcohol over here, one alcohol over here, and they have given you Collins reagent. What is Collins reagent बेटा? Collins reagent क्या होता है? MnO2. Now, अब देखो this carbon, अब ये जो कार्बन है, sorry, कहाँ गया? Let's change the color. देखो, now this carbon, ये कार्बन जो है, this is my carbon next to a double bond, इसको हम बोलते हैं allylic carbon. This is my allylic carbon. So this alcohol can get oxidized, बट क्या दिस अल्कोहल इज एलाइलिक अल्कोहल, ये इस कार्बन में लगा है, दिस कार्बन इज नॉट एलाइलिक, राइट? सो इस कार्बन का देयर विल बी नो ऑक्सीडेशन। बेटा यहाँ पे प्रोडक्ट क्या बनेगा? द प्रोडक्ट विल बी वेरी सिंपल, प्रोडक्ट यहाँ पे रहेगा डबल बॉन्ड, this converted to ketone because it is tertiary alcohol, and this primary alcohol will remain as it is. I hope clear है, right? Great. Now copper in 300 degree Celsius ना, ये क्या करता है? This also does the elimination, ये elimination का काम करता है। मतलब what how to do elimination? मतलब elimination मतलब we'll be doing dehydrogenation। dehydrogenation मतलब removal of water, right? So basically how we'll do, मान लो इसके लिए what we take generally copper in 300 degree Celsius, ठीक है? copper in 300 degree Celsius, this is a general reaction और it follows elimination mechanism, ठीक है? Now कैसे करते हैं बेटा इसमें? देखो, for this one let's say they have given you any alcohol, मान लो RCH2OH, primary alcohol is there, ठीक है? They have mentioned copper in 300 degree Celsius, अगर copper in 300 degree Celsius is there, primary alcohol है बेटा, primary alcohol always converts to aldehyde, तो तुम इसको क्या करो, you convert to RC। let's say I have secondary alcohol, मान लो कोई ring में I have attached alcohol and I have copper heating at 300 degree Celsius, यहाँ से ये जाएगा and you will be getting, ठीक है? and dehydrogenation मतलब by product will be hydrogen gas, hydrogen gas निकल जाएगा। I hope this is clear, right? वैसे ही there was one more reaction, if you remember there is something we have learned that is called as Rosamond's reaction। रोजेमंड्स रिएक्शन याद आया? रोजेमंड्स रिएक्शन हमने पढ़ा था। व्हाट इज द रोजेमंड्स रिएक्शन बेटा? रोजेमंड रिएक्शन क्या होता है? रोजेमंड्स रिएक्शन मतलब विल बी डूइंग द रिएक्शन विद पॉइजन कैटलिस्ट। पॉइजन कैटलिस्ट क्या था? विल बी डूइंग द रिएक्शन विद हाइड्रोजन इन PDBSO4, that is Rosamond's, and if I take PD in CaCO3, वो क्या था? That is my last catalyst, right? Now यहाँ पे if I take RC double bond OCl, ठीक है? and if I do the reaction with H2 in PDBSO4, what this will do? This will remove the Cl from here and this will be converted to RC double bond OH, ठीक है? और साथ में बाई प्रोडक्ट क्या बना? HCl is the byproduct, ठीक है? This is how we used to do the reaction. So basically if you have if you have this one acetyl chloride, uh, then always you will be getting the corresponding aldehyde as the byproduct, ठीक है? So we'll do this much for today. Next reactions will be continuing in the next class, ठीक है? And if you have any doubts or something, you can let me know on my WhatsApp, right? Sure. Thank you so much.